In this video, we are going to look at lots of word problems. So this might be a big one, but hopefully it'll give you lots of examples to work from as you work through the homework and worksheets and all that good stuff. So, before we begin, some concepts here that can be helpful, because with these, we're going to have to set up the system of equations first. And with our systems, what we're looking for are two linear equations. So that's something we need to keep in mind. And as we set up these linear equations, if there's two of them, they often represent two different scenarios. So as I read through these word problems, I'm kind of trying to think about these two different scenarios. What we also have are two unknown variables. Again, our final answer with all of the previous cases was a coordinate, where we had an x coordinate and a y coordinate. Now here, once we have context, it isn't about a coordinate, but it is about like an x value and a y value. You can change those variables, but that's the main idea. So we have two unknowns that we're solving for here. So starting out by defining those can be helpful. Then we can form the equations, and then we can use all the methods that we learned about to get solving. Okay, so the Lazy Daisy Landscaping Company placed two orders with the nursery. The first order was for 8 rose bushes, I'm just going to highlight that, and 4 fruit trees, which totaled $232. The second order was for 6 rose bushes, 2 fruit trees, for a total of $140. The bills do not list the per item price, so we don't know how much each rose bush or each fruit tree cost. So what did each of them cost? And what I'll recommend is usually that like final question that they ask, or often the question that they want us to answer. It's going to tell you what they want our variables to be. So we're going to have two variables. Let's call them x and y. And we want to know price per rose bush. And we want to know price per fruit tree. And then our two scenarios that we have here is our first order and our second order. So we're going to have the results of that first receipt and the second receipt. Because both of these are a combination of buying some fruit trees buying some rose bushes, buying some fruit trees, and ending up with the total cost for both of these. So that first order, we got 8 rose bushes, 4 fruit trees for $232. So we could see here is we have our quantity, and what we would do is multiply that quantity by the price per rose bush. So that would give us our total cost for the rose bushes. We have 4 fruit trees, and whatever the cost is for each fruit tree, combining those would give us the total cost of the fruit trees. And we add those together, that would be our $232. And then from our second order, we have 6 rose bushes, 2 fruit trees, for a total of $140. So with that, we have the setup for our system of equations. We have two equations here, and we could get solving. So let's go ahead and move these over here, and now we can do some algebra. 6x plus 2y equals 140. Okay, I'm going to go with elimination method here. I'm going to cancel out those y values. I have 4y and 2y, but let's go ahead and multiply by a -2 on both sides so that I have 8x plus 4y equals 232. And then distributing the -2, we'll have -12x minus 4y equals -280. Okay, so adding those together, 8 minus 12 is a -4x. 4y minus 4y turns into 0. Perfect. Bring down the equal sign. 232 minus 280 is going to be negative 48. Divide both sides by negative 4, so we're going to get a positive 12. So there's our value for x. And I just need to solve for y. So let's go 8 times x plus 4y is 232. We'll have 8 times 12, which is 96. Subtract 96 from both sides. Let's see, 232 minus 96 for 136. Divide both sides by 4 for 34. Okay, so we got x, we got y, and what we should end with is a nice sentence answer that actually answers the question. So what did each rose bush and each fruit tree cost? And actually, before we make the sentence, we should really check our answers. So plugging in 12 to make sure it works and plugging in 34 to make sure it works. Let's go ahead, just for the sake of time, just go to our sentence. So each rose bush is $12 and each fruit tree is $34. Okay, and that would be our final answer with a nice sentence that finds those two variables for us. All right, let's look at some more cases. So we have a school fundraiser, sold a total of 200 tickets, and raised a total revenue of $550. There are two types of tickets. We have adult tickets that sell for $3 each, child tickets that sell for $2 each. Find how many of each type of ticket were sold. So that last sentence there, find how many of each type of ticket were sold. So our two types of tickets, we have adult tickets and child tickets. So X is going to be the number of adult tickets. And Y is going to be the number of child tickets. Okay, we sold a total of 200 tickets. So that means the number of adult tickets plus the number of child tickets is going to total 200. So one of our scenarios is just quantity, the number of tickets. The other scenario is going to be the revenue that we're making. So we make $3 per adult ticket plus making $2 per child ticket, and that total revenue came out to $550. So we have our two scenarios right there. Okay, let's go ahead and I'm going to do substitution method with this one. So I'm going to use that first equation. I'm going to go ahead and solve for x, which would mean x is equal to 200 minus y. So I'm going to pick up that expression for x and plug it into the other equation. So 3 times 200 minus y plus 2y is equal to 550. Go ahead and distribute the 3 in. Let's see, and I'm going to run out of room right there, but subtracting 600 from both sides, let's see, that'll be a negative y equals negative 50. So y is going to be positive 50. And then we have that x plus y is equal to 200. So x plus 50 is equal to 200. So x is going to need to be a 150. So to answer the question, find how many of each type of ticket were sold, we have 150 adult tickets and 50 child tickets were sold. And just checking our answers. So they add together to 200, so that's perfect. 3 times 150 would be 450, plus 100 would be 550. We're all good. And that would be our final answer. Okay, few more examples here. We have a plane traveled 1,680 miles each way to Phoenix and back. And that 1,680 miles is each way. The trip there was with the wind. It took 14 hours. The trip back was into the wind, which took 24 hours. Find the speed of the plane in still air and the speed of the wind. Okay, so some things that I'm seeing here. We have distance. We have time. And our question is about rate. I'm thinking we're going to need our DIRT formula. Distance is equal to rate times time. So with that, I'm going to make my handy dandy little table. Let's see. We're going to go the trip to Phoenix and the trip from Phoenix. And we're going to make a table so that we can describe distance, rate, and time for each of those scenarios. And then we'll see how this comes together. So this probably isn't looking much like a system of equations, but is because we're going to have that DIRT formula for what's happening to Phoenix. We're going to have that DIRT formula for what's happening from Phoenix, and then we'll combine them together. Okay, so to Phoenix, so the distance each way was 1,680. It took 14 hours to get there, so we have 14. And then on the trip back, that's a long trip, it took 24 hours. Okay, now with the rate, we have two pieces to the rate here. We have the speed of the plane and just still air. We also have the speed of the wind. So let's call our two variables. Let's say R is the speed of the plane. And let's call, I'll say W equals speed of the wind. Wind. Okay. So as we're going to Phoenix, we're going with the wind. So we have the speed of the plane plus the speed of the wind. The wind is pushing us along, making us go faster. So the overall rate is fast, whereas on the trip back, we're going against the wind. So we have the speed of the plane, but we need to take away the speed of the wind. It's slowing us down as we're going from Phoenix. So our two equations, we have 1,680 is equal to R plus W times 14. We also have 1,680 equals R minus W times 24. And now this is starting to look more like a system of equations. So I'm going to go ahead and distribute. Same thing down there. And just rearrange. So we're going to have 14R plus 14W equals 1,680. And then we're going to have 24R minus 24W equals 1,680. And then I'm going to decide elimination or substitution. I'm going to play around with, I'm going to see what 1,680 is easily divisible by. 1,680, does it divide by 14 nicely? It does. Okay, I'm going to do substitution. So I'm going to take, how about I solve for r there? So I'm going to have 14r is equal to, subtracting that 14w, so negative 14w plus 1,680. I'm going to divide everything by 14. I did that just to make sure I didn't end up with any messy fractions. So r is equal to negative w plus 120. And let's go ahead and pick that up, that negative w plus 120, and plug it into the other equation. So 24r, except I'm substituting in for r, minus 24w is equal to 1,680. So negative w plus 120, distributing the 24, so negative 24w plus, let's see here, 240. Nope, 24, what was it? 24 times 120. Too many things at once there. 24 times 120 for 2,880 minus 24w equals 1,680. So let's see, negative 48w, and we're going to have 1,680 minus 2,880 for a negative 1,200. And we're going to take that answer divided by negative 48 for 25. Okay, wind speed is 25, which means the rate is, and we can go ahead and plug it in right here. Rate is negative 25 plus 120, which would be 95. So that's our value for r right there. So the speed of the plane is 95 miles per hour, and the wind speed is 25 miles per hour. And there we go. So we can use those dirt formulas, the distance, rate, time. I find the table really helps me just kind of organize my thoughts and get away from the big chunk of text that we have. And then from there, we can find our system of equations to solve. Okay, one more example here. I told you this was going to be a big one, but I just want to show you lots of examples to use. So we have Eugene asked you to make 14 gallons of fruit punch that contains 29% fruit juice by mixing together some amount of brand A and some amount of brand B fruit punch. Brand A contains 20% fruit juice, and brand B contains 50% fruit juice. How much of each do you need? Okay, let's go ahead and use A and B here. So A and B, we're going to have amount of brand A and amount of brand B. Okay, so, and these answers, that's going to be in gallons. I find the units can help a lot, especially when organizing the system of equations, just knowing your units on the variables you're solving for. So we're making a total of 14 gallons. So I'm going to have that amount of A, that amount of B added together is going to give us 14 gallons. Okay, that was the nice part. Now let's look at the concentration part. So what we can say is whatever amount of brand A we're using, 20% of that is fruit juice. So what I'm going to do is go, if I take 20% of A, or 0.2 times A, that's telling me how much fruit juice I have within that number of gallons. And then what we can do is combine that with that 50% of brand B. So what this is doing is it's giving me a total amount of the actual fruit juice that we're getting. We're getting 20% of the amount of A, 50% of the amount of B to give us our total amount of fruit juice. So that total amount should equal, in our final result of 14 gallons, 29% of that will be fruit juice. So we're taking 29% of 14. So we have a little calculation to do on that right-hand side to figure out the actual quantity of fruit juice. So let's go ahead and simplify that down. So we have A plus B is 14, and we have 0.2A plus 0.5B is equal to 29 times, 0.29 times 14, which is 4.06. All right, there's our system of equations. I'm going to go ahead and use substitution method. So I'm going to solve for A in that first one. So A is equal to 14 minus B. And then I'm going to go ahead and take 14 minus B and not plug it in there, plug it in here for A in the other equation. Okay, so we have 0.2 times 14 minus B plus 0.5B is equal to 4.06. Let's go ahead and distribute the 0.2. So 2.8 minus 0.2b plus 0.5b is equal to 4.06. And we will have, let's see, 0.3b equals, and let's take 4.06 minus that 2.8, 1.26, and then divide by 0.3, for a 4.2. And then A is going to be equal to 14 minus the 4.2 to give us 9.8. Okay, so how much of each do you need? We need 9.8 gallons of brand A and 4.2 gallons of brand B. There we go. Okay, thanks for bearing with me there if you made it to the end of this, but hopefully that covers lots of scenarios for you to use as you work through word problems with our systems of equations.